Hello. Okay, so I'm gonna continue off from the last video where we left off. Okay, so um, if you guys watched the last video, so I introduced this idea of a logarithmic expression. So one way to think about this is if you see this, you want to think what exponent are you raising the base of 6 to get 216. So if you try to do this, 6 times 6 times 6 is going to be 216. So this means log base 6 of 216 is going to be 3. Now, same idea with this one. So if you see a logarithmic expression, you're trying to think what exponent are you raising the base of 9 to get 1 over 81. So if you try to do that, 9 raised to negative 2 is going to be 1 over 81. So this means log base of 9 of 1 divided by 81 is going to be negative 2. Okay. Now, there is a way that you can calculate this using Desmos or graphing calculator. Now, I understand that all the graphing calculators are at school. So because all the graphing calculators are at school, using graphing calculator probably isn't possible unless you have one at home. So in order to get around this, we're going to use Desmos. Okay. So one of the formulas that I want to show you is this change of base formula. Okay, so the change of base formula can be applied to logarithms. So if you see some expression like this, log base b of x, it equals log of x divided by log of b. Okay, so some examples here. So if we took that first example, so let's say we did this here. So log base 6 of 216 is the same thing as log of 216 divided by log of 6. So in this case, x is 216, b is 6. Okay? And then what you can do is you can type this into Desmos and you can get an output, which is the same as what we have here. And the same idea goes for this one. So if you have this log base 9 of 1 over divided by 81, it's the same thing as log of 1 divided by 81 divided by log of 9. So if you type this into Desmos, then you're going to get negative 2. Okay, so I'll show you how to type that into Desmos in the examples that we see here, but I want to just give you the general idea. Okay, so next part. So some logarithms aren't as easy to solve as the ones above. So let's say I give you this log base 5 of 9. So in other words, you're trying to think what exponent are you raising the base of 5 by to get 9? Okay, so if you try to think what exponent, kind of like the other problems, you try to think, okay, well, how many times can I multiply 5 and then how can I get 9? So if you try 5 to the first power, that's going to be 5. If you try 5 times 5, which is 5 squared, you're going to get 25. So what this means is 9 is between 5 and 25. So this means this exponent is probably going to be somewhere between 1 and 2. 1 and 2 here. It might be somewhere less than 1.5 probably, just based on what I see in the numbers. But anyway, so we can manipulate this expression log base 5 of 9, and this is the same thing as log of 9 divided by log of 5. So if we use Desmos here, you can use Desmos and you can actually calculate what that exponent is. So what this means is if you plug in 1.365212 back into here, 5 raised to that power is going to be about 9. So that's what I wanted to show you there. Okay. Now, instead of me just talking about this, let's just show you how this works. Okay. So let's say you want to evaluate the following expression using Desmos or a graphing calculator, and you want to round to the nearest 1,000. Okay. So what I see for this problem here, I'm going to actually, let's see. Sorry, I'm going to just come up here. I'm going to take this part. Okay. So if you try to do this, so log base 6 of 14 is the same thing as log of 14 divided by log of 6. So what this means is if you went and used Desmos and you type in log of 14 divided by log of 6, you're going to get this nice little value here. So this value is going to be 1.473. Okay, so 1.473. Okay. So the next part, let's say we have this one. So we're trying to find log of base 20 of 9 divided by 4. So if you just do this, this is basically log of 9 divided by 4 divided by log base 20. So if I were to type that into decimals, so just log of 9 divided by 4 divided by log 20, then I'm going to get, is that what it was? Yeah, so 0.2707. So this is going to be 0.2707. Okay, so this would be the answer for this part, and this would be the answer for that part. Okay, so next what we need to do is I can consider the other problem. Okay, so oh wait, sorry, this is rounds to nearest thousand, so this is 7.1. Okay, anyway, so this one, log base 12 of 30, so same idea. So all you do is it's the same thing as log of 30 divided by log of 12. So if you just type into decimals, log of 30 divided by log of 12, this is going to be 1.369. 1.369. 1.369. Okay. Now this one. So if you try to do this one, hopefully you guys see a pattern already. This is going to be log of 29.53 divided by log of 11. So all you're doing is typing that in, log of 29.53 and divided by log of 11. So this is 1.412. So 1.412. Okay. Log base 4 of 3/7. So same idea. So this is going to be 3/7, and this is going to be 4. So all you're doing is typing it into decimals. Log of 3/7 divided by log of 4. Yeah. Oh shoot. Okay. This is negative 0.611. Yeah. Negative 0.6 11. Yep. Okay. All right. And then we have this one. Okay. So log base 14 of 1. So same idea. So this is going to be log of 1. The bottom here is going to be 14. So if I just type that in, log of 1 divided by log 14, and that's going to be 0. Okay, and that's pretty much it. So this is how you would evaluate those expressions using decimals. Okay, that pretty much summarizes this video. I'm going to save the next part for the next video.